Hello everyone. In the last video, we derived the equation of an ellipse. What we want to do in this video is we want to start getting practice with working with ellipses. Before we do that, I would like to go ahead and talk about some vocab that go with ellipses. So, ellipses can have two different orientations. We can have an ellipse that's elongated more in the x direction, or we can have an ellipse that's elongated more in the y direction. Okay, and just like we saw in the last video, we're going to be thinking about these ellipses for right now having their center at the origin. So this will be the coordinate 0, 0. The distance from the origin to one of the foci will be c. What I like to call the larger radius, there's kind of like a bigger radius and a smaller radius. The bigger radius we'll always call A, the smaller radius we'll always call B, and that's independent of the orientation. Here we still have the longer radius is A and the shorter radius here is B, and still the distance from the center to a foci we call C. Also, I don't want to clog up these pictures too much, but ellipses are symmetric. So this distance here is C, which means that this distance here will also be C. This distance here is A, the distance here will also be A. This distance is B, this distance here will also be B, and that'll be the same for this picture over here. Now, the equation of ellipses have the form x squared over a squared plus y squared over b squared is equal to 1, or x squared over b squared plus y squared over a squared is equal to 1. Sounds like a lot, but the best way to think about it is just thinking about in which direction is the ellipse elongated more in. Before I talk about that, one thing that I need to make super clear is that the way I'm labeling these, A is always going to be bigger than B. We'll always assume that A is bigger than B, and that both of these will be bigger than 0. So for this one, let's notice that it's being elongated more in the x direction, so that means that the a squared will go under the x squared. So this will be x squared over a squared plus, and you can kind of think it's being stretched in the y direction by b. So since there's a y squared, there will be a b squared. This will be equal to 1. Okay, I know that the a squared went under the x squared because it's being stretched more in the x direction, and we use a to talk about the longer radius. Now over here, we're going to have an x squared. Okay, well it's being stretched by kind of like a factor of b in the x direction. So I'll think about an x squared all over a b squared. Plus, then we'll have a y squared. Well, the y is kind of being stretched kind of by a factor of a in y is being stretched by kind of like a factor of a, so the a will go under the y squared. This will be equal to 1. Okay, so whatever the larger number is, that's how it's being elongated more. So for example, if we had something like x squared over 27 plus y squared over 13 would be equal to 1, this ellipse is going to be elongated more in the x direction. Okay, or if we have x squared over, 19 plus y squared over 21, this is going to be elongated more in the y direction. Here, since it's being elongated more in the x direction, our a squared would be 27 and our b squared would be 13. Over here, we're being elongated more in the y direction, so a squared will be 21 and b squared will be 19. Okay. So some other things that we'll want to talk about are these things called the major axis and the minor axis. So the line segment, if I'm thinking about this as the larger radius, this would be like the larger diameter. So the line segment that kind of contains the larger diameter, we call the major axis. Okay, and the line segment that contains kind of like this shorter diameter, this is what we call the minor axis. And that'll be the same over here. This will be the minor axis. And from here to here, this will be the major axis. Now, for the minor axis, let's think about its length. The length of the minor axis will always be 2b. 1, 2, 1, 2. It'll always be 2b. The length of the major axis will be 2a. 2a for both of these. Okay. You might sometimes hear something called a minor axis and a semi-major axis and a semi-minor axis. A semi-major axis is just kind of like half of this line segment. So this would be the semi-major axis, and this would be the semi-minor axis. The length of the semi-major axis would be A, and the length of the semi-minor axis would be B. Okay. So another common thing that you might hear is something called a vertice. So what a vertices are, the vertices of an ellipse, are the endpoints of the major axis. Okay, so I'll arbitrarily label these. Let's call this one here V1, and we'll call this one here V2. They'll use capital letter V's with numbers to talk about the vertices. So V1, V2, and this will be V1, and this here will be V2. The endpoints of the major axis. So let's write that. The vertices will be the endpoints of the major axis. Endpoints of the major axis. Okay, so I'm kind of trying to draw a line here to separate the vertices of the one that's elongated more in the x direction and then the one elongated more in the y direction. The vertices for this one, what will be the coordinates of the vertice? Well, from the origin to one of the vertices, that'll be a length A. So this here will also be a length A. So V1 will have coordinates negative A and 0, and V2 will be A and 0. Over here, let's see, the vertice, or V1, well, now the vertices are along the y-axis. Here the x-coordinate will be 0, the y-coordinate will be negative A, and V2 will be 0 and A. These are the vertices. As far as I know, there's I don't know, maybe there's a name for them, but not that I'm aware of. There isn't a name for these 2 points right here. As far as I know, we just call the vertices the endpoints of the major axis. I don't know if there's a name for the endpoints of the minor axis. Okay. Let's now talk about foci. Okay. Oftentimes, you'll see capital F's to talk about the foci. So this one we'll call maybe F1, and we'll call this one here, how about F2? We'll call this one here F1, and this one here F2. And there's really nothing special about why I called one 1 and the other one 2. Okay. So the coordinates of the foci, so here we're talking about the foci. For this one, the coordinates of this focus, let's see, F1 is going to be, well, this length here is C, so we go, for F2 it would be, what, C and 0. For F1 it'll be negative C and 0. And F2 will have coordinates C and 0. Over here, F1, our first focus will be what? We'll have an x-coordinate of 0 and a y-coordinate of negative C. And F2 will have an x-coordinate of 0 and a y-coordinate of C. Okay. Well, a useful tool that we actually saw in the last video is a relationship between the A's, the B's, and the C's. Oftentimes when you're given the equation of an ellipse and maybe you're trying to sketch it, you want to try to figure out where the focus is. But you would only know what A and B are. So how can we figure out what C is? Okay, I'm going to draw this picture. So the key thing to remember about an ellipse, the key thing to always remember about an ellipse is how we constructed it. We took two dots, and we tied a string to them. And we knew that no matter where our pencil was, that the length of the string would be the same, which means that this length plus this length will be the same regardless of where we are on the ellipse. That was the geometrical definition. Well, what we noticed, or try to figure out a little bit more information about the length of our string, is that if we picked convenient locations where we put our pencil, for example, if we put our pencil right here, here's one foci, here's the other foci, our string would go from here, it would go to our pencil, and then from our pencil, it would go backwards. So the thing to realize here is if we were to cut this string, this kind of lower piece right here, and move it over here, we can actually see that the length of our string, we cut here, moved it here, the length of the string is really the same thing as the length of the major axis. We should make a note of it. The length of the string, if you were drawing an ellipse, is the length of the major axis. It's the length of the major axis. From here to here, we find to be A. From here to here, we define to be A. So the length of the string is the length of the major axis, which is equal to 2A. Well, what helped us get a relationship between our A, B's, and C's was that the length of the string was 2A, and also we put our pencil at another convenient location. This picture I'm about to draw you here is the one I always draw myself. Okay, so here's our foci. Okay, we're going to put our string right here. Okay, well, the length from here to here is what we called the C. Called this C. And the length from here to here we called B. And, well, let's think about the string here. Well, the length of the string is always 2A, but I put it at a convenient location, or we put our pencil at a convenient location, so that this is half the string and this is half the string. So if the entire length is 2A, then this length here must be A, which means that this length here must also be A. So with this picture right here, we see this gorgeous right triangle. And if we use the Pythagorean theorem here says that, well, the Pythagorean theorem says that the square of the hypotenuse length is A. So the square of the hypotenuse is equal to the sum of the square of the legs. So if we know what A and B are, we can easily figure out what C is. We could just solve for here. Notice that C squared, if we subtract B squared from both sides, C squared is the same thing as A squared minus B squared. Okay. This is a nice, important formula to hold on to. But again, I mean, it's good to have things memorized, but when I forget something, I kind of go back to the basics. We got the string, we're creating an ellipse. We can figure out that the length of the string has to be 2A. We put our pencil at this convenient location. We get this beautiful right triangle, apply the Pythagorean theorem, solve for C, or at least solve for C squared, and we can figure out what, we have now a relationship or a way to figure out what C would be if we know what A and B are. Okay, the last kind of vocab thing I want to talk about is something that's called eccentricity. So, while I guess I drew this picture here where the shape was elongated more in the x direction, we would still have the same relationship here if it was elongated more in the y direction. Okay, eccentricity. Eccentricity. This is a measurement about kind of how elongated an ellipse is. say it measures how elongated an ellipse is. I don't know if I spelled elongated right. I don't know if there's one or two L's, but you know, I'm a math major. Okay. So what is the eccentricity defined to be? Okay. So instead of me drawing you a bunch of hand-drawn pictures to show you why eccentricity is is defined this way, I'll show you an animation here in just a moment. But the length from here to one of the focuses, or one of the foci, is what we call C, and the length from the center to one of the vertices is what we call A. Eccentricity, we use the letter E, not to get confused with our famous number E. This is not Euler's number. The eccentricity is defined to be the ratio of C over A. It's the ratio of C over A. Now, what's good to note about the eccentricity and how it works is the eccentricity, will always be between 0 and 1. Okay. In this case, if it's closer to 0, okay, this is going to be more like a circle. The closer the eccentricity is 0, the more circle-y the ellipse will be. So if we're closer to 0, it's more like a circle. It's more like a circle. If the eccentricity is closer to 1, I'm going to think it's kind of more like a straight line, or it's more elongated. And what I mean by that is, if you were to take this ellipse, and super elongate it, you'd be getting closer to kind of like this straight line, Or if the eccentricity is closer to 0, we're going to get a circle. Okay, and I'll show you an animation in just a moment, but I guess notice that if C was 0, well, if C is 0, that would bring the two foci close to one another, and we'd only have a single foci, and that's going to be a lot like a circle. In that case, if our C value is 0, 0 over a number will be 0. So that's why if the eccentricity is 0, it'll be more like a circle. But if C is kind of stretched out more, if C is kind of getting closer to A, like if here is C and here is A and here is A, this ellipse is going to be super elongated. Super elongated. Okay, and since C is pretty close to A, C is almost the same as A, or pretty close to A, so this would be getting something closer to like A over A, which would be closer to 1. So that's why, kind of with just some hand-drawn, or so, trying to give you a loose argument. But if C is 0, it'll be more like a circle. The closer that C is to A, the closer that this will be to 1, which will be closer to kind of super elongated straight line. But let's take a look at an animation of this. We'll see you there. Hello, everyone. Let's go ahead and take a look at an animation to help us understand eccentricity and why it's defined to be C over A. This is the same animation that we saw in the last video. You can find a link to it in the descriptions, or you can find a link to it on our WAMAP page. Let's go ahead and turn the foci on, so we can take a look at those. And let's also scroll down, and these last windows here show you some of those, the vocab that we saw on the whiteboard. So let's first look at the ellipse without the strings attached. So here's our ellipse. And what I have here, this will show us the semi-major axis A. So the semi-major axis is like half of the major axis. So that's from the origin and then all the way to kind of to one of the foci. So this will be the semi-major axis. And then here we have the major axis. So this will be this all the way. I guess it's the line segment that connects the two vertices. And then we have the semi-minor axis. That'll be from here to here, and the minor axis from here to here. Okay, but let's take a look at the eccentricity. So I'll click this on here, and what I have down here is this is showing us the C length, so from the origin to one of our foci, and this is our A length that'll be from the center to one of our vertices. And what it's displaying here is the eccentricity, so this is the ratio of C to A. So right now it's saying the eccentricity of this ellipse here is roughly like, what, 0.83, so kind of close to 1. Notice it's pretty elongated. But let's actually go ahead up here and let's change the value of C. So if we change how far the foci are out from the center, we're going to make this ellipse much more elongated, much more elongated. I'm actually keeping the length of the string the same. That was what we used for L right here. So that's why A is not changing. Remember, the length of the string is 2A, so 3.5 is the length of the string. Cut that in half, that's 1.75. But if we make C, if we get C closer to A, we're getting a much more elongated shape. And notice here that the eccentricity is getting closer to 1. It's getting closer to 1, and if they're exactly the same, well, then we just kind of get this straight line here. But if we decrease the length of C, if we're taking the ratio of C to A, if we make the foci closer to one another, we're going to get much more of an ellipse that's much more like a circle. And look at the eccentricity here. It's getting closer to 0. So right when it is 0, we have a circle. We only actually have one foci rather than 2. Okay. Again, if C is getting closer to A, then we have a super elongated. The eccentricity is going to be closer to 1. C is a little bit smaller. Bring the foci closer together. We're going to have something, an eccentricity that's closer to 0, and we're going to get a shape that's much more like a circle. So there you have it. Let's go back to the whiteboard and do some examples. Now that we've got a lot of the vocab out of the way, let's go ahead and get some practice working with ellipses. Let's first get practice with graphing. Okay, so let's go ahead and graph. How about x squared over 25 plus y squared over 9 will be equal to 1. Okay, I want us to label the foci, and the vertices, and also the endpoints of the minor axis. And let's also calculate the eccentricity. Okay, go ahead, pause the video, and give this a shot. Okay, let's do it. Let's first note that the x squared is being divided by the larger number, so this is going to be elongated more in the x direction. So that tells us that a squared is going to be equal to 25, or if we square root both sides, a will be equal to 5. 9, this will be our b squared. Well, b squared will be equal to 9, so b will be equal to 3. Okay, we're going to need to find the foci, so maybe we should do that now. So we need to figure out what C is. Well, you could draw your picture. We can remember that C squared will be the same thing as A squared minus B squared. So our C squared will be equal to, well, our A squared was 25. And our B squared was 9. So we have that C squared will be equal to 25 minus 9. 25 minus 9, I think that'll be 16. So we'll have C will be equal to 4. Okay, let's go ahead and sketch. Let's go ahead and sketch the ellipse. Okay. We need to go out 5 units in both directions along the x-axis from the origin. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, and in the y direction, we need to go up 3 and down 3. Okay. So here's a rough sketch of our ellipse. Okay, This will be one of the vertices. I don't know, we can call this one, I guess, V1. It'll have coordinates -5, 0. This will be another one of our vertices. Okay, it has coordinates 5 and 0. Okay, this is one of the endpoints of the minor axis. Okay, so this is the point, this will be the point 0, 3. This point here will be 0 and -3. Okay, we need to label the foci. Okay, so the foci and the vertices will always lie along the major axis. So it'll lie along the x-axis in this case, and I need to go out 4 units from the origin. So 1, 2, 3, 4. So here's one of our foci. So I should have put a V2 here. So this will be one of our foci. Here will be the other one. So we will call this focus 1. It has coordinates what? -4, 0. And this focus here will have coordinates 4 and 0. Okay, so here's our ellipse. The last thing we need to do is we need to figure out the eccentricity. So the eccentricity is defined to be C over A. So the eccentricity, let's see, our C is 4. Our C is 4, and our A is 5. Okay, so 4/5, I think this is going to be 0.8. So here's our eccentricity. Okay, let's do another example. Okay, let's say we have x squared over 9 and y squared over 64. Go ahead and pause the video, sketch this ellipse, and find these features, or label these features and find the eccentricity. Okay, let's do it. Let's notice that the y squared is being divided by the bigger number, so this is going to be elongated more in the y direction. Okay, this is telling us that a squared is equal to 64, so a will be the square root of 64, which is 8. Okay, this 9 here, this will be our b squared. Our b squared will be equal to 9, so take the square root. B will be equal to 3. We can now figure out our what our c value will be. So c squared is equal to a squared minus b squared. So in this case, c squared is going to be equal to, what, 64? 64 minus 9. So 64 minus 9, that's going to be 55. If we take the square root, c will be equal to the square root of 55. This isn't a nice whole number, but we can use our calculators, and the square root of 55, is roughly 7.416. Okay, so let's go ahead and sketch the ellipse. Okay, so we need to go 8 units in the y direction from the origin. So here's 8. Here's 8. Okay, our b was 3, so we need to go in the x direction 3. Okay, so here's our ellipse. Okay, this will be one of our vertices, this will be the other one. So I don't know, I guess I was calling this one V2, doesn't really matter. So V2 will have coordinates, what, 0 and 8. There's one of our vertices. Okay, this one right here. V2 will be -8 and 0. Okay, this point right here is 3, 0. This point right here will be -3, 0. Okay, our C is roughly, I don't know, 7.14. So here's 7, I don't know, roughly 7.5-ish. So this is where one of our foci will be. This is where another one of our foci will be. Okay, so this is, call that our second foci. It has coordinates, 0 and the square root of 55. And this one right here which I'll call f1, has coordinates 0 and the negative square root of 55. Okay, the last thing we need to label, or the last thing we need to record, is the eccentricity. So the eccentricity will be the ratio of C over A. And just looking at this picture, I mean, look how close C and A are to one another. I mean, I'm expecting this to be a number pretty close to 1. So the eccentricity, the square root of 55, all over 8. We can use our calculator. So the square root of 55 divided by 8, we're getting 0.927. So notice that the eccentricity for this example was bigger than the last example. That means that this ellipse is more elongated than the ellipse in the previous example. Cool. Okay, so that's all there really is to graphing these. Let's go ahead and do some examples where we're given some information about an ellipse and we want to find its equation. Okay, so find the equation of the ellipse let's say with foci say f1 at 5, 0, and let's say f2 at negative 5, 0. These are arbitrarily numbered. It doesn't matter if I called this f2 or f1. You might also see that the book, sometimes you might see they'll say the foci are at plus or minus 5 and 0. You might see this notation. Okay, and let's say the length of the major axis, let's say, is 12. Okay. Go ahead and pause the video and see if you can come up with this equation. Okay, let's do it. You don't have to draw a picture. It might help you to draw a picture. Specifically, we just want to make sure we have our orientation correctly. Okay, the foci at plus or minus 5 and 0, the foci are actually along the x-axis. This means it's going to be elongated more in the x direction. Okay. So, I don't know, we'll just say this is 5, this here is negative 5. Okay. Here's our foci. So what this tells us is actually, this tells us what our value C is. We know C here will be 5, so let's record that. We know C is 5. Okay, what else do we know? We know the length of the major axis is 12, so if we were to draw the ellipse, I guess if the length of the major axis is 12, remember that the length of the major axis is equal to 2a. So this is telling us that a, if we divide both sides by 2, a will be 6. So we could write 6 here. Here's a negative 6. So again, this is just, I don't know if this is exactly how the ellipse is going to look, but it'll be something like this. Okay, so that tells us that our A is going to be 6. Okay, so right off the bat, I know we have the equation x squared over a squared plus y squared over b squared will be equal to 1. Okay, we can already fill some of this in because we know what a is, but we need to figure out what b is. So if I know A and C, we can figure out B with the, I don't know, with that nice Pythagorean, that nice Pythagorean, or the nice right triangle relationship that we drew. We know that A squared is equal to C squared plus B squared, or A squared is equal to, I don't know, B squared plus C squared. Okay, so B squared will be equal to A squared minus C squared. Okay. So our b squared will be equal to, what's our a? Our a is 6, so 6 squared will be 36, minus our c is 5 squared is 25, so our b squared Let's see, 36 minus 25, what is that, 11? Okay, so b will be the square root of 11, but I don't really care about what b is unless I'm trying to graph this, but we're just asked to find the equation of this ellipse, and I just need to know what b squared is. So the equation should be x squared, okay, a was 6, a squared will be 36, plus, okay, well, our b squared is 11, will be equal to 1. So here is the answer. Okay, let's do another example. Let's find the equation of the graph of, let's find the equation of the set of points let's say whose distances from, let's say, 0, 4, and 0, -4 add to 10. Go ahead and pause the video and see if you can find the equation of this shape. Well, since we're in the ellipse section, you're probably not surprised that this is going to be an ellipse. What we want to do here is we want to find the equation of the set of the points whose distance from these 2 points add to a constant. That is the geometric definition of an ellipse. So in this case here, these must be the foci. These must be the foci. So if we're drawing the ellipse, okay, here's one foci, here's the other, okay. This one here, 0, 4. So, I don't know, this distance here is 4. This distance here will also be 4. These are our 2 foci. I guess I could write this. I don't know, we'll call this F2, 0 and 4. And we'll call this one F1. Will be 0 and -4. Okay, we're finding the set of points that basically if we were to connect our string, we'd have a string length of 10, and we'd be able to draw our ellipse. Well, one thing that we learned is that the string length is always equal to the length of the major axis, or the string length is always 2a. So this is telling us that actually 2a is going to be equal to 10, or that a will just be 5. Okay, so we must have a 5 here, and we must have the -5 here, or this will be one of the vertices. Say that V2 must be at 0, 5, and that V1 will be at 0, -5. Okay, again, we don't need to draw the ellipse. That's not really what it's asking. We just want to find the equation. Well, we know that A is 5. We know that C is 4. So A is 5. C is 4, and it's going to be elongated more in the y direction. We just need to figure out what b is. Okay, we have that a squared is equal to b squared plus c squared. So b squared will be equal to a squared minus c squared. So here we have that b squared is going to be equal to 5 squared, 25 minus 4 squared. So that'll be 16. So we have that b squared will be equal to, what, 9? Or b would be 3. But we really just care about what b squared is. Okay, so the equation will be x squared over b squared plus a y squared over an a squared will be equal to 1. Okay, b squared is 9. So we'll have x squared over 9 plus a y squared over, what was our a? 5. So 25 will be equal to 1. And here is our equation. Okay, let's do another example. Okay, let's find the equation of an ellipse. Okay, let's say that the eccentricity with eccentricity, how about the square root of 5/3? With foci, along the x-axis, and the length, let's say, of major axis is 12. Okay. Go ahead and pause the video and see if you can find the equation of this ellipse. Okay, let's do it. The first thing that's really speaking or really kind of yelling at me is that the foci are along the x-axis. So if the foci are along the x-axis, that means it's elongated more in the x direction. Okay, so we're going to have something of the form x squared over a squared plus y squared over b squared will be equal to 1. Okay, we know the length of the major axis is 12. We know the length of the major axis is 12. So from here to here is 12, which means from here to here will be 6. This is telling us that A will be 6. Okay, that A will be 6 here. Okay, now what we need to figure out is we need to figure out what B and C are. We need to figure out what B and C are. Well, the one thing we really haven't used quite yet is the eccentricity. Okay, so the eccentricity is defined to be C over A. Okay, and that's the same thing as the square root of 5 over 3. Okay, here's one of the biggest mistakes I see students make. Oh, the eccentricity is C over A, and that's the same thing as root 5 over 3. So you might think to yourself, oh, hey, that must mean that C is root 5 and that A is 3. But this is incorrect. This is incorrect. We actually just figured out that A was 6. We actually just figured out that A was 6. So this can't be right. We have to be a little bit careful because this is most likely a reduced fraction. So what we need to do is we actually need to plug in the value for A. So let's move this over here. Our A value is 6, so we actually have that C over 6. C over 6 is the same thing as root 5 over 3. So let's solve for C here. Okay, we'll multiply both sides by 6. So we'll get that C is the same thing. Well, this 3 can divide into the 6. So C should just be, that'll be a 2 now. So it'll just be 2 root 5. So we know our C value. Okay, well now that we know what C is, I guess, just hold on a second. Notice here that the eccentricity C is 2 root 5, and our A was 6, but this reduces to root 5 over 3. So be careful with these type of problems. If they give you the eccentricity, you can't necessarily say that the numerator is C and the denominator is A, because they could be giving you a reduced fraction. Okay, so we know our C, we know our A, we can figure out our B. Okay, we had that A squared was equal to B squared plus C squared. So we have that B squared is equal to A squared minus C squared. Okay, well what's C squared? Okay, what happens if we square both sides? Okay, if we square both sides, we're going to get 2 squared. So 2 squared is 4 times the square root of 5 squared. The square root of 5 squared is just 5. So we have that C squared is going to be equal to 20. C squared will be 20. Okay, so B squared. Our A was 6. So 6 squared will be 36. And C squared is 20. So here we have that b squared will be, what, 36 minus 20? That'll be 16. So our answer, remember we're just trying to figure out what b squared is. Okay, so we're going to have x squared over a squared. It's elongated more in the x direction, so that'll be 6 squared, or 36, plus a y squared over b squared, which is 16, will be equal to 1. And there we have it. Okay. Let's do a couple examples with shifted ellipses. Let's start and let's graph. Let's say the problem gives us, we want to graph 9 times x plus 1 squared plus 36 over y minus 2 squared is equal to, how about 324? Okay, well, what's kind of funky about this problem right off the bat is, well, usually we're used to things of the form a squared, or x squared over a squared plus y squared over b squared is equal to 1, or the a's and b's could be switched, but we're used to it being equal to 1 here. So this is not in a great form. The first thing we want to do here is clean this up. Let's divide everything by 324. Divide everything by 324. So we can have it being equal to 1. Okay. Half the battle of math is having things in an appropriate form. Okay, so let's do, instead of doing 9 divided by 324, let's do 324. 324 divided by 9. So we have 324 divided by 9 is the same thing as 36. You could think of this as 36 over 1. So 9 over 324 will be equivalent to 1 over 36. And similarly, 324 divided by 36. 324 divided by 36 will be equal to 9. You could think of that as 9 over 1. So 36 over 324 will be equal to 1 over 9. So I can replace this 9 divided by 324 by a 1 over 36. Or if I multiply that in, this will just be a 1 over 36. Or a x plus 1 squared over 36. So we'll have a x plus 1 squared all over 36 plus we'll have a y minus 2 squared over 9 will be equal to 1. So now we're in a good form. Okay. So what we should notice here is really if there wasn't this plus 1 here or minus 2 here, this would just be an ellipse with its center at the origin, and we'd have, in this case, it's elongated more in the x direction, we'd have our a squared would be 36. So here we're going to have that our a squared is going to be equal to 36, and over here we're going to have our b squared is going to be equal to 9. Okay, or how about our a will be 6 and our b will be 9. Okay, now let's think about where the center of our ellipse will be. So our center, well, since we're adding 1 to x, this is going to shift the ellipse to the left 1 unit. And since we're subtracting 2 from y, this is going to shift the graph up 2 units. So the center of the ellipse will be at -1 and 2. So now we're just going to make all our measurements from this central location. Okay, so let's do it. Okay, so let's go back 1 unit. So here's -1, and here's 2. This will be our center. Okay, it's stretched more in the x direction, so I need to go in the x direction from the center, 6 units. Remember our A is 6, and our B is 9. Okay, so we'll need to go 6 units, so 1, 2, 3, 4, 5, 6, so this will be 5. 1, 2, 3, 4, 5, 6. What will this be? What, -7? Okay, we need to go up. B is 3. B is 3. Be the square root of 9, so I need to go up 3 units. So this will be at 5. And we need to go down 3 units. So here's -1. Okay, so we can draw our ellipse. Okay, so here's our center at -1, at -1, 2. This will be one of our vertices, so this will be, I'll call this one V2. It has coordinates 5, 2. This will be another one of our vertices. We'll call this one V1. Have coordinates -7, 2. Okay, the coordinates right here will be what? -1, 5. The coordinates here will be, looks like -1, -1. The only thing that's left to do is to find where the foci are, so we need to figure out what C is. Okay, well, we have that C squared is equal to, or we have C squared is equal to A squared minus B squared. Okay, so our C squared is going to be equal to 36 minus 9. 36 minus 9. So we're going to get that C squared is going to be equal to, what will this be? This will be 25. Or our C is going to be 5. Okay, so from the center, we need to go 5 units to the right and to the left. Remember the foci and the vertex, the foci and the vertices lie along the major axis. So let's go 5 units to the right and left. 1, 2, 3, 4, 5. So here's one of our foci. 1, 2, 3, 4. Here's our other foci. So we'll put -6. This will be -4. So this will have coordinates -4, 2. This foci, I don't know, we'll call this one, how about F2? Call this one F1. That has coordinates -6 and 2. And there we have it. Okay. Let's do one more example. Let's do an example where we're given information about a shifted conic and we want to find its equation. Hey, how about a shifted conic, a shifted ellipse? Okay. Let's find the equation say of an ellipse with vertices. Let's say V1 is -3, 7, and V2 is, how about -3, -3, and foci, let's say F1, be at, how about -3, 5, and foci 2 will be at -3, -1. Go ahead and pause the video and see if you can find the equation of the ellipse with these properties. Okay, let's do it. I think it's going to be nice to plot these points. Okay, so one of the vertices is at -3, 7. So here's -3. Here's 7, so -3, 7. This will be one of the vertices. We'll call this one V1. Okay, and -3, -3. Here's the other one. So we'll call this one here V2. Okay, the foci, one of them is at negative 3, 5, negative 3, 5. So here's one of our foci. And negative 3, negative 1. Okay, here is our other foci. Okay, now the thing to realize here is this is already telling us about our orientation. All of these points, the foci and the vertices, are lying along a vertical line. This is telling me that the ellipse is going to be elongated more in the y direction. So the general equation will be x minus h squared all over, well, I guess b squared, and then x minus k squared y minus k all over a squared, because I know it's going to be elongated more in the y direction. Okay, we need to figure out what h and k are. That's just going to tell us the coordinates of our center, and we need to figure out what a and b are. Okay, I think we can easily figure out what a is. Well, I think to find any of this, we actually need to find the center first. Okay, so the center is going to lie halfway between the two foci, or halfway between the two vertices. Hopefully we can see that its x-coordinate will have to be negative 3. The x-coordinate will be negative 3. Okay, now let's try to figure out the y-coordinate. Okay, so you can either find the y-coordinate by averaging negative 1 and 5, or you could find the y-coordinate by averaging negative 3 and 7. Either should give you the same answer. Let's do 5 and negative 1. So what number is halfway between 5 and negative 1? Going to be 2. So it'll have a y-coordinate of 2. Okay, so that'll be right here. This is where our center is. So our center is at negative 3, 2. Okay, we can give a rough sketch. So I don't know, the ellipse is going to do something like this. This isn't an exact sketch, but just a loose sketch. All right. So let's see here. What do we know? Okay, well, we can figure out what our C is going to be. So this will be our C length. So this will be our C. Okay, and C, well, we could find the distance between 5 and 2. I hope you can see that's 3. Or we could subtract the y-coordinates from this focus and the center. So that'll be what? 5 minus 2. So C is going to be 3. Okay, if we want to figure out what A is, okay, the distance from here to here, this is going to be A. Okay, we could find the difference between, I guess we could count, here's 7, here's 2, so I hope you believe that should be 5, or you could take 7 minus 2, that'll give us 5, so A should be 5. Okay, so A squared will be 25, we still need to figure out what B squared is. Okay, so we have that A squared is equal to B squared plus C squared, so B squared will be equal to A squared minus C squared. Okay, A is 5, so A squared will be 25. C is 3, so C squared will be 9. So we'll have that our B squared will be 25 minus 9, which will be 16. Okay, so I think we have everything that we need here. This being the center, okay, this tells us that our H is negative 3 and our K will be 2. So the equation will be x, or you could think that we're shifting it to the left 3 units, so we should have an x plus 3, or it'd be an x minus a negative 3, which would be a plus 3. Okay, b squared is 16, plus what our y, we're shifted up 2 units, so that should be y minus 2 squared, all over our A. Our A was what, 5? So 25 will be equal to 1. So here is the answer. Beautiful. Okay, that's all we have to do to talk about ellipses. In the next video, we'll talk about our last conic. We'll see you there.